Okay, today we're demonstrating a flange assembly demonstration unit produced by J. Genco. We'll be compressing three different styles of gaskets, one being a WR Lamons style spiral wound gasket, which does not have an inner ring. The second being a Lamons WRI standard spiral wound gasket, which has an inner ring, and a Lamons LP3 cam profile style gasket. You can see with the software with the J. Genco unit, the chart on the left displays bolt stress in individual bolts, and the chart on the right shows gasket deflection. We're just using a standard cross tightening pattern with a 30, 60, 90% of final torque, those three passes, and then a final chaser pass of 100%. Here we've got the torque wrench adjusted to 30% of what the final torque will be, and we're tightening bolts 1, 5, 3, and 7. And you can see on the chart on the left that the bolt stresses are increasing. You can see with the chart on the right that the gasket is compressing as well. And here we have the same torque setting on the first pass, and we're tightening bolts 2, 4, 6, and 8 in that cross tightening pattern. And you can see the load is reduced on 1, 3, 5, and 7 as we tighten the bolts next to them 2, 4, 6, and 8, and as the gasket continues to compress as well. So we've adjusted the torque wrench to 60% of the final torque, and we're back to bolts 1, 5, 3, and 7. And then again, because of the bolt interaction and the joint elasticity and the gasket continuing to compress, you can see that the loads continue to shift throughout those two sets of bolts. Here we tighten 2, 4, 6, and 8 at that 60% setting, and you can see there's a constant struggle to maintain that load as the gasket continues to compress. Here we are at the third pass, 90% of the final torque, tightening bolts 1, 3, 5, and 7. And again, you can continue to see that elasticity in the joint and the interaction of the bolts. And the third and final pass, 2, 4, 6, and 8 at that 90%. And you can still see a very significant difference in the two sets of bolts that we've been tightening there, and that's again because the gasket continues to compress. So here we've adjusted the torque wrench at the 100% setting, the final setting, and we're just going to do a circular pass, no cross tightening at all. And from this you'll see that the loads will somewhat gain some consistency. You can also see with the right, or the graph on the right, that the line is starting to turn completely vertical, and that's because the windings have been completely compressed, and the flange has bottomed out on the guide ring itself, so there's no more deflection left in the gasket. So that was the first circular pass, and we're just going to go around one more time just to try to gain some consistency in the bolted joint. Okay, you can see that the circular pass had a pretty significant impact on gaining some consistency there. And we'll just go again just to make sure none of the nuts are turning. That's essentially what an operator would do in the field. You can see our average bolt stress there in the lower right is around 63,000 psi bolt stress. So we're going to unbolt this flange and show you the gasket that's been compressed there. Again, that's a style WR spiral wound gasket without an inner ring. Okay, this is a standard Lamons spiral with an inner ring, same pressure class and nominal pipe size. We're going to load this up the same way. The chart on the right, you'll see that the compression curve we're going to leave on the software, and you have the ability to do that. Where when we compress the next gasket, we can overlay those compression curves and compare the gaskets and see how they relate to each other. So we're going to simulate exactly what we did on the spiral wound gasket without the inner ring with a gasket with an inner ring. So we're back to the 30% of the final torque, bolts 1, 5, 3, and 7. And you can see the new compression curve starting to generate on the graph on the right as well. So same tightening pattern, same tightness stress, and we are tightening bolts 2, 6, 4, and 8. You can still see that interaction between those two sets of bolts. We adjusted the torque wrench to the 60% of the final torque, and we're back to 1, 3, 5, and 7. Notice that the gasket with the inner ring maintains a significant amount of tightness, and you can tell by the line, the compression line being more to the left on the graph, and this indicates that the winding is able to withstand a higher amount of load, and that's because the windings are fully trapped between the inner and outer ring, and you prevent a lot of relaxation in the winding. So we're at the third and final pass of bolts 1, 5, 3, and 7 at 90%. And you can still see that struggle between the sets of bolts as we continue to compress. And here's 2, 4, 6, and 8. One thing to notice is that because of that inner ring, you don't see the discrepancy between the first set and the second set of bolts as you're tightening it. It's a much closer scatter in bolt load. And here we have the 100% final torque, and we'll just do a circular pass. So you can see a fairly consistent amount of stress throughout all of the bolts, and again that's due to the inner ring and its ability to help stabilize and hold the winding in place. And you can also see that compression curve is much more consistent when you use an inner ring. Again, we've got an average bolts press of around 63,000 psi, so our final load is very consistent to what it was before. But the compression characteristics between the two gaskets are quite a bit different. So there's the spiral wound gasket with the inner ring. And again, if you were able to see it a little closer, you would see that there's no winding deflection, obviously, because the windings are trapped. And this is a Lamons style cam profile LP3. We're going to do the exact same bolting pattern on this style gasket. And again, we're going to leave the compression curves there for both the WR and the WRI gasket, and you'll see how this compression curve differs from those two. So we're adjusting the torque wrench back down to 30% of the final torque value. And we'll tighten bolts 1, 5, 3, and 7. And notice the compression curve on a cam profile gasket, since it's a solid piece of steel and it doesn't have windings. The only thing that you're compressing are the facing materials for that gasket. So you'll get a little bit of compression on the gasket, and then the line goes completely vertical almost immediately, and that's because you're compressing a solid piece of steel rather than the actual winding geometry that you would on the other two gaskets. Also notice the consistency among all the bolts when you tighten up something like that, because you're not compressing the gasket like you would on a spiral wound gasket on either of those styles before. You're actually compressing that solid gasket, which helps maintain the load among all of the bolts that are there. So here's the second pass at 60%. And again, you can see a pretty consistent scatter even after you get through that second tightening pattern. There's not a lot of difference between those two sets of bolts. And here's the final third pass of 1, 5, 3, and 7. And you can see those bolts increase in stress, but you don't see as much reduction between the other sets of bolts as you tighten up. So there we are with the final 3 sets, and our scatter looks very consistent among all of the bolts. And here's the final chaser pass, where we'll just tighten this up, but we won't see a whole lot of movement between these bolts because you can already see that the load is very consistent already. Again, notice the line, the compression curve on the right is almost completely vertical. So we saw all of the compression in the gasket displayed early in the tightening process.